welcome back. This is Joel, and in this video we will continue with our discussion on ACI, and specifically we'll be talking about how to connect your ACI environment to the outside world, right? So mainly, let me just quickly show you in the Epic, right? Again, we won't be doing any lab as such. We'll probably be doing labs, all of the labs probably at the end. But let me just quickly show you, just for you to get some kind of a understanding, right? So I think I have some kind of a tenant open here. The stuff which we will be doing today will mainly concern this networking region, right? So if I go down here, you see I have the bridge domains, I have the VRFs, and you see there are two interesting things here: external bridged networks, and then I have something called as external routed networks, right? You can see some basic stuff like BGP, you can see route maps and stuff like that, right? And also you'll also see a little bit of reference to the EPGs, and so I just want to show you where the EPGs reside. So you have the application profile. These are the internal EPGs, right, which are internal to the ACI, and those EPGs reside here. So we'll be doing a little bit of work with this as well, right? So coming back to our discussion, what we are trying to do today is mainly try to connect our ACI to the outside world, right? So what do I mean by that, right? So technically this is how it's going to be. So you've got to have your spines, say spine 1, spine 2. We've got our leaves here, right? Now, so when you have something like this, generally, unless you're doing a greenfield deployment, right, you will always have a need to, extend your network outside or connect your ACI to the outside world, right? Because though you might have some of your clients hanging from here, right, this is going to be there, but at the same time, you probably will have, or maybe let me just get rid of one of the guy, right? So let's say you will have clients connecting or hanging from your existing ACI, infra, but then you will also have a situation where, one of the leaf will be connected to some kind of a switch, right? And you might have a client hanging from here, right? So in that case, how would you, or for a minute, let's actually get rid of this. Let's get rid of this link, right? For example, let's assume that you have a small data center somewhere outside, right? Now, in ACI, you really don't have an option to take this guy and connect it to the spine, right? So this option is not there, because spines are allowed to only connect to the leaf, right? They can't really connect to anyone else. So coming and connecting your existing infra onto the leaf is really not allowed. Cool. So that means the only other option is for you to go and connect to the leaf. Okay. So when you do something like this, right, how do you configure this? So that's very important. That's, how do you take care of the networking part, right? So that is one very important question. The other one is, so this looks to be very much of a L2 connection, isn't it? Because you're connecting a switch. But not just that, you might have a core network, right? You might have like a proper, core network with, like, I don't know, maybe multiple dual routers, right? Dual home routers, something like this. And in that case also, you would have to come and connect it this way, right? You'll have to, and this will probably, go down to some other gateway, and it might go down to some internet and so like this, right? Now the problem here is, right, you will have, because this is a core network, right? I'm again simplifying this a lot, but you know how a core network would look like, right? So when you have a core network, you probably have, I don't know, like different types of users. You might have guest users, you might have your DMZ users, you might have some users in your campus. If this is a campus, then let's say there are going to be some buildings, you're going to have some traffic coming from there. So you're going to have users, everywhere. You're going to have users here, you're going to have users here, right? So you're basically going to have, when I say users, you will basically have, people trying to connect to your data center from everywhere, right? So this is another use case. The other one is probably you might have an existing data center itself, right? So you might want to, I don't know, maybe have a L2 connection and connect to that existing data center, right? Proper, traditional data center, right? You might have a Nexus traditional data center and you want to connect, because again, L2 is very much preferred in data centers, because things like, you want to do vMotion and stuff, right? You really need a L2 for that, right? So I'm just giving you a bunch of examples of when, you might need, to connect your network to the outside world. All right. So that being said, let's tackle this step at a time, right? So first thing which we're going to look into is, so till now we have looked into two types of outs, right? So it's going to be, one is your L3 and the other one is your L2. There's nothing other than that. There's just two options, right? But then in this also, to make this happen, there are different again, you know, in this individual options, you have again sub options, right? You can accomplish the same using multiple options. So we'll just quickly have a look at that. Again, we won't be doing any configuration as such, but I want to give you like the technical overview of how to do this, right? So that you know, if you pick up the config guide, you will be able to understand why we are we selecting those options and stuff like that. And obviously down the line, maybe if time permits, I'll also, you know, maybe in the subsequent videos I might pick up a lab and actually show you guys all these things, right? That being said, let's pick up again. So let's do L3 first. So again, let's start with the spines, and I don't know, maybe put in a couple of leaves here, right? So we've got like this looks good, and the last, okay, cool. So we've got that. And we have talked about this. L3 doesn't connect up to spine, it connects up to leaf. So let's say something like this, right? So you have a L3 network here, right? So first things first, the leaves to which, you know, the L3 network connects to, they are called, or actually the leaves to which anything external connects to, they are basically called as what? Border leaf. So, right? So they are called border leaf because that's where, you know, you basically come and connect your external stuff. Now specifically we are talking about L3. So what are the possibilities, right? This interfaces, what are the various possibilities? First one is having a typical L3 interface, normal physical interface. Second option, I can go for sub interface, can't I? Right? What is sub interface? Remember, you know, we have probably talked about in this particular concept in different other networking you know, technologies, right? But you particularly come across sub interface when you have VRFs, right? So you have some kind of a router, you have multiple VRFs on this guy, and you just have one interface. What you do is you kind of you know, convert this link into a trunk, right? And you send multiple traffics for say VRF A, B, and C tagged, right? You tag it and you send it on this trunk link, and on the other side, whoever is there can then take that particular traffic coming on, you know, each of those VLANs and then can segregate it into, I don't know, maybe VRFs or do whatever processing it wants, right? But that's the idea about sub interface. So using one single interface to do to send multiple types of traffic, right? To kind of save up on, I don't know, maybe interfaces. When you don't have any interfaces, you kind of save up on interfaces by making sub interfaces. SVI, the third option is SVI, right? So SVI is again a layer 3, right? So we have, I think SVI is the first thing you get introduced to if you do your CCNA, right? So when you basically router on a stick, right? Basically, when before SVI, this is what you used to do. If you had a you know, switch like this, and you had two different VLANs hanging out from here, and if you wanted to route the traffic between these both, you had to go like this and come like this, right? You had to trunk it and then route it. But then with L3 switches, what you can do is you can route the traffic directly between these both guys, because you can create SVIs, right, for 10 and 20, and you know, the traffic can get routed over that, right? So again, so the use of the use case of SVI is that you can if you use this option for the interface here, you can use the same interface for say L2 out and L3 out as well, right? You can do that, right? So anyway, that being said, so there are three different options of configuring the interfaces. Based on your needs, you can try that. So that's one important thing. Okay, let's assume that you have done that. You have picked whatever is your option, right? The next is whenever routing is involved, what we are trying to do here is extend this L3, right? Extend your ACI by connecting it to an L3, right? Whenever routing is involved, routing protocols are involved, right? So you might be running something here already. You might be running OSPF, right? So ACI supports three routing protocols, right? It supports OSPF, it supports EIGRP, and it supports IBGP as well, right? So any of these protocols can be used to do what? To kind of exchange routes in this way here, right? So you might have OSPF, you might have EIGRP, IBGP, or whatever, right? You can use this, right, to exchange the routes, or you can have in your traditional network. And on the ACI side, I can use one of these three to pair with your L3 network, right? Now this is where it gets very interesting, right? Now remember, we have talked about we have talked about the whole architecture of ACI, right? If you remember, let me just jog your memory. You have the tenant, then inside tenant you have the VRF, and inside VRF you have the bridge domain, and inside bridge domain comes your EPGs, right, where the contract comes into play, right? Now few things important here. Where are your subnets going to reside? They are going to reside inside bridge domains, right? This is where you define your subnets. So you might have a, I don't know, maybe subnet like let's not use 10, maybe something different this time. Maybe, I don't know, maybe 20.0.0.0/24. This is the subnet, and its corresponding gateway, whatnot, is configured for this particular bridge domain in your ACI, right? So and you also have the VRF here. So this particular subnet belongs to a particular VRF, right? Because the bridge domain belongs to that particular VRF, right? So you need to tread carefully here when you do the routing here, because it's not very simple, because the whole ACI is a multi-tenant architecture. So you're going to have multiple VRFs, and inside that VRFs you're going to have multiple subnets belonging to different bridge domains and so on. So what is the protocol which is really used in such a scenario? Can you kind of try to map this to a traditional service provider, right? Remember, if you go back to my channel and if you see stuff under MPLS, you will see me doing extensive work on MPLS L3 VPNs, right? And the protocol which was used there was MPBGP, right? So let me try to map this out for you. So what we are going to do is, let me just get rid of this, right? So I think get rid of this as well, so we know the protocols and all of that. So if I have to map this out for you, I could basically call this external network as a CE, right? A customer edge router, right? Think of that way. And the leaves are going to be your Ps, right? Now, you kind of get the point, right? So you have your Cs, right, or your L3 network, which is connecting up here via some interfaces onto your leaves, right? So the interfaces will obviously be, when you set this up, they'll be part of some kind of a bridge domain, right? Which in turn will be part of a VRF, right? So this is literally nothing but your C connecting up to some kind of a P, right? This is PEC or CEP, whatever, kind of a relationship over here. Now the C could be running any kind of routing protocol. In this case, we have talked OSPF, AIGRP, IBGP, right? So when it comes in to the P, right, first thing what you have to do is you have to do the redistribution. Why? Because between P's, what is the protocol which is used, right? The protocol which is used between them is MPBGP. And why MPBGP? We have talked about this before, because MPBGP basically supports, right, not just your IPv4, IPv6, but also the other address families, right? Especially for your when VRFs are involved, your IP address is no longer your 32-bit, right, address. It gets quite big, I think 96, because you're basically adding your route distinguisher, which is a 64-bit, right? You're basically adding that to 32, and as a result, right, it becomes a different address. It's no longer your IPv4 address, and to accommodate that, that's why we go for this multi-protocol BGP, right? So imagine this way: we have the C or the L3 network coming in through the leaves, which are your Ps, right? And between the Ps, we are going to be now running MPBGP. Now again, if you go back to my MPLS stuff, you will see that I think you don't even have to do that. We know that for MPBGP, or specifically MPIBGP, right? We for the neighborship to be established, or for peering between MPIBGP, between the Ps, there are two options. Either you go for a full mesh, because it's IBGP, right? So you have to go for a full mesh kind of a neighborship, which means this guy will have to peer with this one, this guy will have to peer with this one, this guy. So you understand the point, right? Imagine if you have a big data center, you probably will have so much peerings. That's not optimal. So obviously BGP has a solution for this. Use route reflectors, right? So in this case, what they do is they convert these spines into route reflectors, right? So you can configure this as the route reflectors, and now what will happen is your Ps will form MPBGPs, obviously with the route reflectors this way, right? And that way, my PE has to form just one, or in this case, for redundancy, if you have two route reflectors, it just has to form two neighborships with two of the route reflectors, and all the external routes which are coming in, right, will come into a particular VRF. From there, it obviously it gets converted to a VPN v4 route. From there, it goes to the route reflector, and the route reflector reflects the routes, and all the other leaves which have that particular VRF will get those routes. So that way, everyone in the network or every leaf will now come to know about the L3 network and the users which are behind it, right? So hope that was clear. So we are using our traditional MPBGP here. Reason is because literally you're no longer gonna have IPv4. It's all different kinds of address families, and to support that you really need MPBGP. And I also kind of gave you an overview of why we use route reflectors and how you can draw analogous relationship to your traditional kind of service provider kind of a network. Awesome. So that's good. Now coming back to our let me just try to get rid of this a bit. It's too much information here, and let's get rid of that. That's gone. All right, so what we have done till now, we have kind of like this is the border leaf, right? And we have realized how we can kind of go and connect your L3 network to your ACI. That's good. But then what's the end game here, guys? What's the end game? Final part. I mean, the whole idea of having this is so that you can kind of control your external network, or the users who are coming from this external network, right, into the ACI. You should be able to apply your policies on them as well, right? You should. So now the very next step is, after you do this, what have we done? We have configured some kind of routing protocol here. We have also set up this whole MPBGP. All of this is automated for you. You don't have to configure anything on the leaves and spines. Everything is like using the correct checkboxes, correct drop downs. You just go and configure everything what I told you just now, right? What are the everythings? Routing protocol, MPBGP, and inside MPBGP the route reflectors, right? So all of this you can configure using automated steps, drop downs, checkboxes. That's it, right? Cool. So once you have done this, now you have your routes coming in. But the very important thing is policies, right? So this is very important, right? So now you might have something like this. So let me just again get rid of that. So yeah, so policy. So you might have like two subnets here hanging out of this L3 network. Maybe you have 10.0.0 network, and probably the other one probably could be like 20.0.0.0 network, right? You're going to have two subnets, and the users are coming from here, right? So now you have two options. So the reason is the end game which I was talking about is policies, and policies is nothing but EPG here, right? That's the more important word. So you have to somehow categorize the users who are coming from outside into the corresponding EPGs, right? So when you create this external network, right, external routed network, I showed you over here. I hope it's not timed out. Yeah, here, right? When you go here and create the external routed network, right, you also need to mention what kind of subnets are going to come in, right, and which EPG they are going to belong to. So you have an option. You have actually two options here. One is I can go with the lazy option, and I can say something like 0.0.0/0, and I can say basically everything which comes from L3, put it in a particular EPG, right? It's a lazy option, I would say. Like if all the users who are coming from outside literally belong to one EPG, and I can go for this. I can say anything coming from this particular L3 out, go for. So this is literally called as L3 out, right? So anything coming from L3 out, put it in this particular EPG, right? That's a lazy option. Or I have another option where for the same L3 out, for one single L3 out, I can create multiple EPGs as well. And I can create it based on this IP subnet. I can say, look, if it is coming from this guy, let's go with, I don't know, maybe EPG 1. If it is coming from here, let's categorize the traffic to be EPG 2. Right? I can do that. So once the traffic comes in, right, once we have categorized into corresponding EPGs, then, it's literally handled by ACI, right? And while we are here, let me take a minute to explain a little more about contracts, because I think in my previous video on the logical constructs about contract, I missed out a very key point. Probably maybe because of the rush, I kind of missed one important point about consumers and the providers, right? So you have your contract, something like this, generally, right? And I've told you, if you have a EPG, I know maybe this is a web EPG, and I know maybe there's one more EPG. Let's go with some application EPG, right? So let's say web wants to web wants to connect to application EPG, or web wants to talk to application EPG. So the traffic has to flow like this, in which case your contract or access, right, is going to flow in the opposite direction, this way, right? Which means if the traffic has to flow from web to app, right, the contract, right, the blue in color, has to flow in the opposite direction, which means this app engine or the app EPG, right, has to provide access to the web, right? So because this guy is providing, this guy is called as the provider, whereas since this is the guy who is using it, he is called as the consumer, right? As simple as that. Very, very straightforward, very literate as such. There is nothing complicated here, right? Just always remember this. The traffic flows in one direction, the access flows in the opposite direction, right? The access construct, right, is basically taken care by contract. And when you create a contract, you have to, after creating the contract, you can attach that contract to any EPG. So when you attach it to a particular EPG, you have to tell for that particular EPG, is it getting attached as a consumer or it is getting attached as a provider? So this kind of sets everything clear, right? So now same thing over here as well. Since you have created this EPGs inside your ACI, you have told ACI, look, traffic coming from 10 is EPG 1, traffic coming from 20 is EPG 2. Now I can simply go and create a new contract of this sort, right? And I can, maybe, I don't know, maybe you want this EPG 1 to talk to some EPG inside your ACI, right? Or you want EPG 1 to talk to EPG 2, whatever it is, right? You can define the contracts over here similar to how you would define if it is a normal ACI network. All right. What else? So the other thing is, let's do a quick packet walk maybe, right? So a quick packet walk, which means I really need to get this out of the way. There's too much content here. Let me just give me a second. Let's grab that. And actually this one can be there. I think it should be fine. Let me just grab this. Let's get rid of that. And yeah, okay, that's good. Cool. So let's assume that we are on probably, I don't know, maybe one of the leaf here, right? And we are in a particular subnet. Let's not use 1020. Let's say we are on 30, right? I don't know, maybe 30.1.1.1, something like this, right? This is literally a server which is connected to my ACI, right? Now the question is, when you're doing a packet walk, how would 30.1.1 will be able to talk to one of these guys? Maybe, who knows, maybe there is a user who is 10.1.1.1. How will 30.1.1 talk to 10.1.1? Obviously, the packet will first come to the leaf, right? And the leaf will check in its endpoint table. In the endpoint table, it will not find 10.1.1, right? Which is the next table it is going to check? Obviously, the routing table, right? And the routing table, right? Routing table is attached to what? It is attached to a VRF, right? So in the VRF's routing table, we are going to have an entry for this subnet. Why? Because it was learned via MPBGP. So now we are basically going to have that particular subnet over there because it was learned, right? And it would have been learned when it was learned, right? In this guy's routing table, it will be written like this. It is going to be that 10.0.0 can be reachable via the VTEP of L3, right? So this guy, this nice guy over here, will create the VXLAN tunnel and it will send the packet like this, right? Obviously, I mean, to this leaf or this leaf, depending on if it's a VPC or whatever, right? But let's assume simplicity, it's going to send to the leaf, and then the leaf will obviously forward it down because, because of the OSPF and whatever the relationship over here, it's going to forward it down to the external network, right? So just wanted to kind of tell you the whole significance of MPBGP, because we are doing the whole of this circus because we want this particular subnet to somehow arrive in the routing table or the VRF's routing table of every leaf over here. Okay. So what else will we do here? Let's give me a second. I think we have pretty much covered everything in L3 out, right? So I think we can now slowly move towards the last discussion of this particular video, which is going to be our L2 out, right? So I think this is kind of clear, at least from a technical perspective. I think it's kind of clear, so we are good. So let's get rid of that, right? There you go. So when we talk about L2 out, right, I think it's very clear. We want to extend the L2 network outside, right? Now again, the use case of this would be, like I said, you have some kind of servers hanging out on your traditional data center, and you wanna do extend it, into your network, right? So think of it this way. So you have your spines, you have a couple of leaves here, right? And I don't know, maybe you've got like a server hanging out from here, right? And you have some, I don't know, maybe like a small data center with like a couple of switches, and you have a server hanging out from here as well, right? So so now in L2 out, you have two options, right? You have two options here. Unlike L3 out, here you have two options, right? So the first option, let me give the example. First option you generally use when you have something like this, right? Imagine you have a database, right? You have a database kind of like a database server, right? And you have one database server in your ACI, and then you also have another database server which is in your traditional network, right? And you've obviously connected it this way over here. The traditional network is connected to your ACI, right? Now in this case, what we really want to do is extend EPG. So this option is called extend EPG, right? So what we do here is because this database server is inside ACI, there will surely be an EPG for this, right? You probably already have an EPG. So how do you draw an EPG? Probably you could draw a bridge domain, right? And I don't know, maybe this is the EPG, right, inside that. So maybe this guy is your database EPG and is already there, right? And let me draw DB here, and he has connectivity with some other EPGs who are there in the network or in the ACI network. What you really need to do in this case is, because you already have that particular EPG in your ACI, you just want to extend, right? You want to just somehow get this workload inside your ACI fabric. So that's why we call this as an extending EPG kind of an option, right? So you basically need to get this guy somehow. Let me just grab that over here. My drawing is terrible today. So over here, right, you just want him to be part of that particular EPG, and that can be done. Pretty simple, nothing very complicated as such at all, right? So what you do is just like how you would do your traditional VPG, right? Traditional EPG configuration, right? The same steps are followed here as well, but the only thing is here what you would do is you will basically tell that you will have to do something called as a static mapping, right? You'll have to static mapping, which means you'll have to define a particular VLAN over here, right? You can maybe have this as a trunk interface, and you can say, look, the traffic coming on, I don't know, maybe VLAN 50, and on this particular port, whatever this port is, Ethernet 1/1 on this particular leaf, you're basically telling, every traffic which is coming out of that, in the VLAN 50, let's go and categorize it as being part of the DB EPG, right? That's basically called a static mapping, and that's the option number 1, static port mapping, right? So pretty simple, right? So we are basically telling our ACI, look, there is a L2 out outside, there are some database servers, and we want those database servers to be part of the existing EPG, and we explicitly tell what are the conditions. We tell which port it is going to come on, and what is the VLAN the traffic is going to be tagged with. Sweet. So that is your option 1. The second option is what we call as extending the bridge domain itself, right? So the extending, so let me again get rid of that. So probably get rid of everything, okay, and maybe this as well. Okay, so in this case what we do is in this case we have it something like this, right? So again, your traditional stuff here, yeah, but the external whatever you have, the external network which you have, again, let's go to the same thing which we had, right, earlier. I know maybe there's a server hanging out from here, but the difference this time is maybe this is a database server, this is some other server, maybe like a web server, right? It's a completely different type of traffic, or different type of an endpoint, right? And you currently say don't have an EPG for that, right? You probably have EPG for database here, right? And maybe you have EPG for I don't know, maybe app application layer as well, but you don't have anything for web, right? So in such situations, you're basically you're creating a completely new EPG, right? So that's where we call as this particular step, which is extending the bridge domain. So that's where we use that option which I showed you here, right? The extend here, right? The extend bridge domain, extend bridge networks. So you go there and you click on that and you say create a new bridge domain, right? So what you're trying to do is, if you look at it diagrammatically, you'll basically see that once that is created on the Apex GUI, you'll basically see the existing bridge domain like this, and you'll see this new guy, this extended bridge domain, whatever it is, hanging out from here, right? It'll look as a cloud, it'll look as, this picture will not be a circle, you'll actually see it as a cloud right over here, and this will appear as whatever the name you would have given for this, L2 out or whatever you would have given for that external bridge domain. It will appear here like this, right? So in that GUI of Epic, right, this is how it will appear. So but then, yeah, you understand the point, right? The distinction between the previous option and this option. When do you use this? And so when you want the external network to separately appear, right, as a completely different EPG of its own, right, that's when you kind of go with the second option, which is extending the bridge domain, right? So that is the thing. Now configuration wise, probably I'll not talk much now. I want to keep that for later, but yeah, that's mainly it. I mean, this obviously will be still connected over here, but the only difference here is what you'll be in this configuration, you will basically go under that existing bridge domain where you want to extend, right? And you will basically or basically actually you'll be going to the create external bridge domain, and there you have option for selecting which bridge domain you want to extend, right? So the internal bridge domain, let's say, I know, maybe it's called BD, and the external one which you want to extend, you'll have to give a name, L2 out, and you can extend, and that there also you will have to define the VLAN, right? So you have to do the same thing like earlier, because you really need to tell ACI, right, about this L2 network and the traffic which is going to be coming. So you'll have to tag your traffic from your external network and say, I know, you have to use the same VLAN, VLAN 50, right? We are basically telling ACI, look, all the traffic coming out from VLAN 50, I wanna, kind of like extend it and kind of create a new external bridge domain, and I also want to create a new EPG for that, right? So now your EPG will start appearing over here. Maybe, I don't know, maybe this is web. And once it appears, obviously we know how we can make them talk to each other, right? We basically go and create the contracts, and we make we put the correct labels, whichever is the consumer, whichever is the provider, and so on, right? So there are two options of that sort. Okay, so that's about connecting to the external networks. The next is probably, I thought probably it's going to be useful if we talk a little bit about spanning tree protocol, right? Because when you talk about this L2 stuff, right, the main problem which you get into is kind of like the STP stuff, right? And we have not talked about STP till now, so it's going to be an interesting thing, right? It's not going to be long, pretty quick. We're going to have a quick discussion on the STP part. All right, so STP. Again, I've been drawing this a lot, so let's try. Okay, hope this is the last time I'm drawing this. So there you go. So we've got the leaves, right? Everything good. So we've got this, right? And now the problem is, okay, that's a mistake. This one. All right. So STP. So we're talking about STP, especially when we talk about this, right? The important thing is, yeah, STP. Let's put the STP up there. Cool. So what we have done is, say we have say a switch here, right? And we have extended, we have done the L2 out, right? We talked about this earlier, right? And I know maybe there is a port channel running here, and you have the clients hanging out from here and everything, right? Generally, this is how you see, right, the L2 networks. You have like switches, they're connected by port channel and so on. And I know some new engineer has come in, he has gone and connected to the ACI. This is what you see. Now, very first thing as a network engineer, what I see here is I see a loop, right? So I see a loop. So how will ACI take care of this? Now, the first point you need to remember is that ACI doesn't process STP, right? ACI doesn't process STP. So STP packets are not processed by, when I say STP, basically I mean the BPDOs, right? Which are like the heartbeat of the whole STP, right? Like if BPDUs are not communicated properly, the whole STP will crumble down, because all the syncing issues, right, all the every single guy, every single switch in a STP domain has to talk to the others through BPDUs to understand who is the root, who is the designated port, designated switch, and all of that. Now, if ACI doesn't process this, that's going to be trouble. So now BPDUs, STP doesn't process BPDUs, but it floods BPDUs. So that's a very important point, right? So that's very important to understand. Now, the problem is with BPDUs, right? If you look at the BPDU packet, right, there are especially with two types of STPs, which are the STPs, PV STP, per VLAN STP, and rapid PV STP. In these types of STPs, your BPDUs are tagged, right? So the BPDUs which are coming from your traditional network, right, they are going to be tagged. Now, when they are tagged, what happens is your ACI will so the flooding of this BPDU is completely different from our data flooding. So don't compare with that, right? We have talked about all the flooding before, right? That flooding is different from here. So what happens is your ACI will flood the BPDUs, but it will flood it in that particular EPG and that particular bridge domain, right? So what I mean by that is if the access VLAN over here, I know maybe let's say VLAN is 10, right? So your BPDU is getting tagged with 10 and it's going on this particular port here, right? Your ACI will basically make sure that when it is flooding, when it is sending it down here, right, it will send it in that particular same VLAN, right? In the same access VLAN, which is VLAN 10, and obviously in the same EPG and same bridge domain as well, right? So if your BPDUs are tagged, what happens is ACI will flood it. Now, when it floods it, what will my external network see? My external network will see it this way, right? It's going to see it this way. So as soon as it sees this, my external network will, if there is STP properly configured, what it is going to do, it is going to probably shut one of the link, or maybe this link, whichever, you know how STP works, right? It's going to shut one of the link, and as a result, what is going to happen? It's not going to shut anything in the ACI, it's going to shut one of the uplinks, maybe this one or this one, right? But this is really good for me, because if my external network is taking care of my STP part, there is not going to be loop now. But the problem kind of comes when this is not true. When are BPDUs not tagged? BPDUs are not tagged when you go for another type of STP, which is the MST, multi-spanning tree, right? So in that, your BPDUs are not tagged. Now that is tricky. So what you do in that case is you do a little bit of circus here, right? So you need to create a separate EPG, right? You'll have to create a separate EPG over here. Let's call it, I don't know, maybe like STP EPG, right? And you'll have to define some kind of a native VLAN, right? I know, maybe native VLAN of, 500, right? So you have to define that, and you'll have to attach it to this interface. You'll have to attach it to this interface. So now what it will happen is all the BPDUs which come untagged, right, they get captured here in this particular EPG, and obviously my STP will kind of like forward it on the same native VLAN on the other switch, right? We are basically kind of, since the tagging is not coming, we are basically manually creating EPG to kind of bypass that scenario, right, to make the flood happen, right? So basically you'll have to attach your L2 out, whichever you have created here on both the sides, to this particular EPG, right, and that particular native VLAN, so that ACI, when it floods, both the sides get it, and as a result this is achieved, and your external STP will come into effect, and one of the link gets shut. Now the simplest thing to kind of get rid of the whole STP issue in ACI is what? Go with VPC, guys. Pretty simple, isn't it? Just go and put in a VPC over here. You will never hear about STP at all. You won't have any issue at all, right? So that's obviously, but then if you really need STP in your network, there is no other option but to do this a little bit of a, let's say around the way, or a bit of a long road with STP. Cool. So hope that was useful. And just to kind of summarize, I think especially on the L2 outside, right? Let me just kind of summarize on L3 outside, I think we are pretty much clear, right? In L3 out, what we do is we kind of Let me just get rid of that. Right, in L3 out, like I said, we have a bunch of things we talked about here. We talked about we are going to have like a routing protocol, say like OSPF, but you can also have EIGRP, IBGP. Then we are going to have MPBGP to make sure the routes are basically kind of the routes which are learned from outside are actually sent to the right VRFs, right? And then we also learned how we can make our the spines as the route reflectors, right? We make them as route reflectors to kind of reduce with the whole peering sessions, right? The probably one thing which I missed is we talked about how the routes enter ACI from outside, but how does the routes kind of leave ACI, right? Which means if I have ACI here and if I have external network which is L3 here, we learned how the routes are coming in, but how are they going out? How are they advertised out? So that is whenever you create a bridge domain, you'll be creating these subnets, right? I don't know, maybe like 10.0, right? When you create this subnet, you have an option over there saying advertise externally, right? You have to check that box. So when you check that box, what happens is when you have a L3 out later, that particular subnet will get advertised out. So now L3 out or L3 network which is outside will know about this 10 network. At the same time, because of OSPF or whatever this routing protocol you have used, the routes which are there from L3 are also learned inside. So that's a two-way kind of a situation, right? So that's mainly it with respect to your L3 stuff, right? Now coming to L2, if I have to quickly review, let me just try to draw a diagram, right? So the first option we learned was, right, you're going to have something like, let's say, a bridge domain here, right? You're going to have a single EPG, right? And you're going to have an existing workload, say like a database server, maybe on a access VLAN of 10, right, which is part of your ACI. But then let me use a different color. This is your this is where the external network comes into play, right? The data center, right? The external data center which is there, which you are connecting via L2 out, right? And there might be a VM hanging out from here, right, which is also a database kind of a VM, right? So in that case, what you want to do is you want to extend this guy. That's why I kind of drawn in the same way. So you want to take this guy and you want to extend it to the existing EPG, right? That's the simplest approach for it, because you have like already a EPG in your enterprise or inside your ACI. You want to just kind of extend into it, right? The second option is contrasting to this, because what you do in the second option is, we grab this. So in second option, you will still have maybe let me draw this, right? This is the second option. You still have the bridge domain. You have your first EPG here, EPG1, and the same thing. Maybe you have the database server, right? Only difference is this time in the second option, we are extending the bridge domain, right? So that's why this bridge domain is getting extended, right? Actually, I should have drawn half before and then extended now. But then, yeah, so you extend the bridge domain. So so that, the new guy which is coming in, right, it gets a new EPG of its own, right? And this whole new network basically now comes as a separate, EPG, right? It gets configured as a separate EPG, right? Something like this, right? So it's still the same bridge domain, right? If you look from an ACI perspective, though we are extending the bridge domain, it's not like a new bridge domain. It's still the same bridge domain, right? The new network comes as a new EPG, and in the diagram in ACI's GUI, right, if you look at it, it will appear like this. It's going to be like a cloud, right? So you're going to have your existing bridge domain. It will be connected to like a cloud thing. So this cloud thing, you can think of it as a L2 out, right? So which is actually still part of the same bridge domain, but yeah, it's just a way of displaying that look, there is a L2 out connected to it, right? And then we also talked a little bit about STP, how ACI works with STP. It doesn't actually process STP BPDUs, but it floods the STP BPDUs in the same access VLAN, in the same EPG and the bridge domain, right? And we also talked about how we can cater to the MST where you don't have tagged BPDUs coming in. So you'll have to do a little bit of extra work by creating a dummy EPG with a proper native VLAN, so that ACI can then take the traffic, take the BPDUs and flood it correctly, right? All right, guys. So thanks a lot for watching. Hope that was useful. Bye.